Welcome to the class, dear students. Today we are going to do in this video, in the last 3 videos we have done all the 3 methods and even the Bernoulli's method. Now in today's video I am going to cover some problems where we can use which type of the method is applicable in for which problem, like this. Now suppose if you have cos square x dx, suppose. Now how to solve this integral? Now we know a formula. What is the formula for cos 2x is given by 2 cosine square x minus 1. So this is the formula for cosine 2x. So we have to use this formula to understand what is 2 cosine square. So cosine square x is what now? 2 cosine square x is given by 1 plus cosine 2x. So cosine square x must be replaced by 1 plus cosine 2x over 2. So in the beginning of my classes, I have given you 2 formulas. What are those formulae? One is cosine square x and the other is sine square x. Sine square x can be written as 1 minus cosine 2x by 2. Cosine square x is 1 plus cosine 2x by 2. So remember this formula to understand. Whenever cosine square and sine square, we have to use these 2 formula. Okay. So now let us see what is integral cosine square x. That means it is 1 plus cosine 2x over 2 dx. Now what it is? It is 1 over 2 plus cosine 2x over 2 dx. Like this you can do, or you can also take 1 by 2 outside and do the integration for 1 plus cosine 2x dx. Like this also you can do. So now what is the integral of 1 dx? It is integral 1 dx means it is x. Integral 1 dx is x. And integral cosine is sine 2x over 2 plus the constant. So this is the solution for the given problem. Now what we have used? We have used the term by term. Do you remember? First method is term by term we have done, where we have splitted like this. The terms are being splitted like this. So this is the term by term integration we have used. So let us now go to the next problem. So the second problem is, let us take suppose integral of theta times of 4th root of 1 minus theta square d theta is there, suppose. Then here by observing here, you should understand that there is theta square here. The derivative of theta square is 2 theta. That means theta is available here. So one function and its derivative are present here. So immediately we should get the idea that you are using the substitution. So what you have to do now? Substitute t is equal to whatever it is there in the square root. This is what you have to take. So that is 1 minus theta square. So what is dt? dt is given by minus 2 theta d theta. But now in the problem there is theta d theta, right? So let us divide by 2, minus 1 by 2. dt gives you theta d theta. So now we can replace this 1 minus theta square as t, and this theta d theta, what is the representation for this? Is given by minus half dt. This is what you can understand. So now let us go to the substitution here. So what is this? This is 4th root of 1 minus theta square is t, and theta d theta is given by minus half times of dt. So now you can take minus half outside, and this is integral of t to the power of 4th root means t power 1 by 4 dt. So what's the value for this? Minus 1 by 2 times of t to the power of 1 by 4 plus 1 over 1 by 4 plus 1 plus the constant. So let us now find out what is the solution for this. minus 1 by 2 into t to the power of 1 by 4 plus 1. I hope all of you know when this LCM how to do it. So 1 by 4 plus 1 means since the denominator here is 4, multiply and divide by 4. Then what you get? 1 plus 1 into 4 is 4 by 4, which is 5 by 4. I hope all of you know this method of finding out the sum of the two fractions here. So let us now rewrite here t to the power of 5 by 4 over 5 by 4 plus the constant. So what it gives you, when there is a fraction in the denominator, we have to flip it, correct? So it is 4 by 5 times of t to the power of 5 by 4 plus the constant. So it is, now 2 gets cancelled here 2 times. So it is minus 2 by 5 times of, now what is t? T is 1 minus theta square to the power of 5 by 4 plus the constant. So this is the solution of the given problem. So this is by using the substitution. So by seeing the problem, you should understand which method you are going to use. So now let us come to the next problem. Let us see the third one now. Suppose you have integral of 1 plus root x the whole cube over root x dx is there, suppose. Then how to take the substitution? Here it is very much clear that 1 plus root x when you take, this value when you take, then this is t because there is a power and this is t, and it is very clear that 1 by root x you cannot split this using the term by term because there is cube here, correct? So the only way we have to follow is the substitution. So now what we do? Substitute 1 plus root x is equal to t. So what is the derivative of root x? Derivative of root x is, root x means 1 by 2, correct? X power 1 by 2. It is x power n by 2 into 1 by 2 into 1 by 2 minus 1 dx is equal to dt. So it is 1 by 2 into x power half minus 1 is minus half, x power minus half dx is equal to dt. So can I write this as 1 by 2 root x dx, correct? 1 by 2 root x dx is equal to dt. So now I have root x only here. You observe here in the given problem you have root x only. There is no 2 here. So what we do? We multiply by 2 to get rid of that 2. So what we do? We write 1 over root x. When you multiply, 2 gets cancelled, right? And this becomes 2 dt. So now let us find out, let us substitute all this now. This whole thing is 1 plus root x. We can replace this whole thing as t, and dx by 1 plus dx by root x, this can be replaced by 2 dt. Okay, so now we write this as integral of t cube into 2 dt. Okay, so now I can take 2 outside. Integral t cube dt becomes t power 4 over 4 plus the constant. Now 2 1s and 2 2s gets cancelled. Now what is t? 1 plus root x the whole power 4 plus the constant. So this is the solution. I hope it's clear. So here also we have used the substitution method. So now let us do one more problem here. Integral of ln x square dx. Try to understand this problem. Now ln of x square, this is meant by ln of x square dx.